Are most of you getting the 184.4?
So,
No.
Who is not getting?
540, 149.
Felix, you're the only one? No, you're getting it.
I don't know how, but I'm getting it.
54,
You're getting it. What do you mean you don't know how?
149.
You're succeeding, Felix. Come on. I'm going to get into like Excel out of Mr. Kate's place.
Wait,
That's
here?
my big it's one of my big objectives.
What should I do?
149.
All right, ready, guys? Okay, we are ready now to optimize.
That one will be 149.
So,
Goodbye.
go to
You
data,
got it. Right there. You're done. Here.
and there you find solver.
149.5.
Juan, you have a problem?
Yeah. Almost done.
Yeah, I don't know.
No, you're almost there. 140, 52.
We'll do it after class. Keep going.
So, before we have used solver to solve systems of algebraic equations. We set one equation equal to 0, and we put all the other equations as constraints. In this case, instead of solving system of equations, we want to minimize our performance measure of objective function that j, that sum of error squared. So our objective has to be that j. So for objective, click where you have calculated the sum of error squared. What do we want to do that? Not maximize, not value of 0, minimize. And I'm going to be changing the values of the two parameters that I'm trying to determine. So click here and select d and tau. So I want to select d and tau. I don't have any constraints. They are non-negative, but I don't need that constraint. I'll only use, and if I do, I would add as a constraint here. So I'll remove the abomination just to get the habit of it. And click solve. Keep solve. So you can see that the values that I got, delay is almost 8. And my tau is 15.6. And you can see how close the model is to the equation. It's pretty close. Best way to see it is in a graph. So, everybody okay? We solve it? You got this? Yeah, I'll go back and solve it. So, objective is what I have typed the sum of error squared. Select minimize by changing cells, select tau and d, and remove the abomination and click solve. Did everybody get the 7.8 and 7.97 and 15.6? Good. Of course, it's always good to see how well our model is doing. So you should all be masters in plotting in Excel. Let's plot the model against experimental data. So let me close that. Select time, y experimental, and y model. Go to insert. Select scatter chart. Let's select the points. And let me move the chart somewhere.
Okay, which one from the scatter? The fifth? Yeah.
Upgrade menu shade so we can see things clearly. And it's a good idea to have the points, the experimental points. Why didn't I get? Oh, here. The experimental points is points and the model is line. So for that, I always try to remember how I do that. I go to design.
Oh.
Can I get the one where I change the markers and things like that?
You can connect the dots.
Quick layout. Okay. Okay, add chart.
Missing one right here. What's 58?
They keep changing how to do it.
What is it that you want to change?
I want to change the model, not to have points, to have lines.
You can go to insert. and
Okay.
Get a different chart. Smooth.
For my data point. That's it.
56 is.
Okay, for my data point. And
That was 48.
click on that.
You're changing?
Change it to solid line.
Wait, you changed the wrong one.
Oh, didn't take all the data.
56 is 148.
Yeah, I can do. Select all of them. Let's have a problem.
This one is.
Maybe here. That's the old way you do it here.
I don't know.
You just click on it.
Okay. There we go.
Create a chart.
So you want a solid line, and you want to remove the markers.
It's closer.
Where's the markers? Oh well.
It's under, go back to, go back. Click on your line. Now go to
Oh, okay, that marker.
marker option.
Okay, marker options. And you can see how close is the model to the experimental data. Okay? So is the method clear to everyone? All right.
No software.
Damn it, I wasn't paying attention.
Now,
Software.
let's move to the game. Now, let's use the slope line method for the game and find the GU for the game. So next I want to find the GU. By the way, I'll be posting your homework assignment after class. There's homework here today. John is in the back, so hand it out to John, please, at the end of class.
Software.
I guess some of them already turned it in. Good. You haven't done it, so not yet. Please do.
Question. What's
Yeah.
this method like actually called?
Is it minimum?
Nonlinear regression. How about that?
Function variable is these two.
Minimizing sum of error squared. Yeah, call it okay, minimizing sum of error squared. That would be good.
Okay, and then quick route.
These two, right?
Yeah.
Which two?
No.
Oh, these two.
No, it's these
Minimizing some.
Now, in all the exams,
But you, why did you move it?
I have had them use this method
Redo it.
for second order model.
Say, a control cut. Or
I gave them the response for second order model, didn't have to derive it.
copy this.
And what would you do if you have oscillation? Then you cannot fit first order plus time delay. Then you would need to fit at least second order plus time delay. So I gave the equation, the equivalent equation for star
Just 3 columns.
for it, and I asked them to do that.
Okay. And
Gave them
then
experimental
scatter
data.
chart.
Trying to find what I had on the exam, but I don't know if I can find it. I may have lost it.
Scatter plot. And then this one.
All right, let me.
Okay, now right click. Right click.
So it doesn't doesn't look like we'll be able to tune the controller,
Right click on
but at least let's try to get it to you. And first thing on Wednesday would be to tune our controller.
new sheet. Okay. Done.
How did you connect those dots? How did you do that?
Hmm?
Go to click on this. Right click.
At your line?
Oh, format this area. Never mind. Cancel.
Oh,
Yeah, line.
Oh.
Configuring Windows.
Line.
Shit.
Line.
Okay, 74.
Which is right colors. Very well.
Cool. Thanks.
Yeah, I went through 20 some updates before class, that's why I left the computer.
So this is when we need Windows?
Huh?
This is the time we need Windows?
Yes, yes, because we're running CSTR game. Actually CSTR comp, which is the version of CSTR game without major disturbances, just with the noise. Yes, Anna?
When you make the line, do you make it for the experimental or the model?
You put the points on the experimental data and the line on the model.
Okay, gotcha.
That's the standard convention.
That's what you do.
All right. So,
Started on Windows.
on class programs, in addition to CSTR game, you have a program called CSTR comp. When do you make those step changes to get your first order class time delay transfer function? When upstream things are quiet. When it's period when you don't have significant disturbances affecting your program. Well, CSTR game has significant disturbances all the time. So, what do? I have a different program, CSTR comp, which is exactly the same system as CSTR game with the same noise without major disturbances. So we're going to run CSTR comp through DOSBox the same way we run CSTR game.
Wait.
Where's your file? CSTR?
So not CSTR game, together with it is the sister program CSTR comp. So bring CSTR comp and drag it to DOSBox.
Oh, this is an awesome.
Yes.
Is it in Canvas?
Say again?
Is that in Canvas?
Yes.
Okay.
Yes. Oh, you haven't downloaded all the class programs from Canvas?
No.
What? Better do it right now, guys. Okay, go to Canvas, you find the CSTR comp on files, download it and drag it to DOSBox.
It's like my I don't have that.
Important thing here, we press U to change the flow of the coolant for the step change. We can also put it in automatic control. Okay, you can see here the controls. A switches to automatic, M to manual, and U changes the manipulated input. And you can add up disturbances, etc., but we're not going to be doing any of that. Okay, press any key to continue, press S to go to the graphical display, and because there are no major disturbances, forever it would be going like that. Just the noise. Whenever, yes, Robert.
What makes it full screen? What button makes it full screen?
S.
Oh.
S triggers between the two screens.
No. Like, how do you make it?
Oh, Alt Enter.
And then you just drag.
DOSBox. You haven't installed DOSBox?
Because I don't have a computer, so I
Ah.
don't.
DOSBox. DOS.
I have a tank on my screen.
S.
S, press S. Alright. Pressing U allows you to make a step change. Now here's change here. 0.91, I'm returning back to the same. Here's the key, guys. It's critical from a practical point of view how big you make your step changes. There are two things that we have to consider. There's a trade-off. If I make the step change too big, remember what model I'm trying to get? A locally valid linear model. Transfer function is a linear model. If I make the step change huge, then the deviation variables become large, so my approximation is not so good. Remember, everything is based on a Taylor series expansion, which means small changes. So from that point of view, large changes are bad. On the other hand, real data are corrupted by noise, and if I make the step change too small, the response is drowned on the noise. So you need to compromise, and essentially you want the size of the step change to be as small as you can, while you can still measure things like T63 and draw a slope line. Okay? Furthermore, if the process was truly linear, it wouldn't have mattered which direction I make the step change. Make it step up or step down. Makes no difference. However, reality is nonlinear. And you're going to get a different model if you do a step change up or a step change down. And what parameters do I want? I want the parameters closest to my nominal steady state where I make the step change from. You get better approximation to the linear model if instead of doing just step change up or just step change down, you do equal size step changes and then average the parameters. So what I'm doing, I'm going to be doing step change up, step change down, and then average the k, tau, and d that I get. Clear? So let's do it with the slope method, and we're going to do step change up, step change down, and average. Obviously, we're not going to finish it today. Also, it's convenient to have in one plot the entire response, and this program scrolls every 100. So it's convenient to make the step change at multiples of time 100. So I'll be sitting with my finger on U, and the moment I hit 500, I'll press U. In your case, the moment you hit a multiple of 100, press U. So let me get ready, set, okay, and wait until I hit 500. Right at the 500, I'll press U. So right now, the float of the cooler has nominal steady state 0.91. I'm debating between 0.3 and 0.4 change. Let's make the step change. Let's make it. So if I make a step change up from 0.91.
What do you type in to get that? What do you type in to get that?
U. Press U, but do it at a multiple of 100.
Yeah.
So I'll change it to 1.31. You see, scroll over, and I may have pressed it a bit too soon. Looks like I made the step change before 500. 498 maybe.
There's no way for me to get it to 500.
Huh? No, any multiple of 100 works.
Oh yeah, you just have to
Any
wait.
multiple of 100.